Patreon. Alright, we're going to go a whole nother direction with this video. This question came from the Raging Rhino himself about Edison batteries. What are Edison batteries? You see, when Thomas Edison died, they cremated him, okay? And there's a very small, extremely valuable amount of his ashes left. And they take a standard lead-acid battery and they sprinkle a tiny little pinch of his ashes in there, and then all of a sudden that battery works way better. No, that's not at all what it is. Edison batteries, and I got my notes. My understanding and or experience with Edison batteries is entirely with the company Iron Edison. So take that for what it is. And also, yo, Tim D, please stand up. Stagehand, we need the spotlight on Tim D. He's the guy over there. Stand and wave. Stand up, Tim. Okay, that's Tim. Do the comment thing, Tim. Tim is one of, if not the residential expert here at the channel on things of the solar variety. And when you do the solar things, you also do the battery things. So feel free, Tim, to chime in at any point. I think we've established here at the channel, especially here on Patreon, that I've done a lot of the solar things and I've done much more of the wind things. But a lot of that has been decentralized off-grid with battery backup or grid-tied with battery backup. So, yay old Iron Edison batteries. We're talking about nickel, iron, and also lithium-ion batteries as compared to the standard lead-acid batteries. Lead-acid is like what's in your riding lawnmower, what's in your pickup truck, what's in your golf cart, what's in your boat. Standard lead-acid batteries. So the nickel iron batteries specifically have better capacity over time, generally 20-ish% more capacity over time than a lead acid battery. So we're talking either amp hour or watt hour here, however you want to quantify it. And I know some people, your eyes have already glazed over and you're like, what? I go there too sometimes with this stuff. I what myself? What? So an upside to the Iron Edison batteries is like your traditional lead acid batteries. You need to top off with distilled water about every month. You should be popping caps and checking to make sure that your water levels are up. You know, and these are batteries that are going to be run in series, in parallel. You know, they're linked together. It depends on a lot on what your electrical system looks like. Is it 12 volt, 24 volt, 48 volt? Are you running through inverters to go back to 120 to 40 volt? And are you grid tied? Are you not grid tied? There's a lot of there's a lot of math and science that happens with these things to make the electrons dance appropriately, because when the electrons don't dance appropriately, things blow up and it's bad news. But part of the electrons dancing is that there has to be water, battery acid in lead acid batteries. And so you need to once a month check that. So the nickel iron batteries, every 6 to 8 weeks you check them. So there's one thing right there. You don't have to top off, you know, it's 50 to 100% longer intervals between topping off your batteries. They're also, generally speaking, bigger batteries, so you're topping off fewer of them rather than a whole bunch of smaller batteries. So there's some time savings there, and it's less of an obnoxious task, I guess would be the phrase that I would use. You also, the electrolyte refresh on those is like every 8 to 10 years, which, understand, we're talking about your battery still functioning 8 to 10 years later, which we'll get into longevity of a standard lead acid battery here in a minute. But every 8 to 10 years, you'll refresh the electrolyte. Now on a lead acid battery, that'd be maybe 5 years. With, I gotta flip my notes over. With the nickel iron batteries, they're better for a constant charging environment. like off-grid with solar or wind trickle charging into them through a charge controller. They just do better with that. The lead-acid batteries can have issues with that, and I mean, look, it does work. Lead acid, it does work. It's working quite well for a lot of people right now. Where the nickel iron and the lithium iron come in is that they just have much better longevity over the life of the system. They cost significantly more up front, but the longevity of the system is impressive. A deep cycle marine battery is rated, and this is where things get weird, right? It's DOD, and it's not Department of Defense. It's depth of discharge. If you, on a deep cycle marine battery, meaning that you can go real deep on the depth of discharge without destroying the battery. If you cycle a normal battery, lead acid battery, deeply, 80% or more of its charge, 50 times, your battery's done. Like, it's done. Now, if you take 50% of the depth of charge off of that battery regularly, anywhere from 300 to 900 cycles. You can do that 300 to 900 times before the battery fails. If you take 20% off, you got multiple years, anywhere between 1 to 6 years-ish battery life. And understand that there is definitely degrees here, depending on what battery you buy and what the ratings are and what voltage you're running, and is it in series, is it in parallel, what kind of charge controller you have. There's so much stuff here, okay? Which is why if you're seriously considering this, you should be working with a professional at this. This is just kind of, we're just scratching the surface here, a precursor to the discussion you should be having with somebody who really knows about this stuff if you're going to invest in this stuff. Hey, Tim, raise your hand. Cool. If you're in the Dallas-Fort Worth Metroplex as well, my uncle-in-law, my wife's uncle, is a certified solar installer and master electrician and a really good guy as well. So if you want to know some more about that, I could probably put you in contact with him. And that's not a shameless plug. A shameless plug looks like go to concentricelectric.com or whatever, because yeah, that's them. But anyway, the nickel iron batteries have an 11,000 cycle lifetime. Not 50, not 3 to 900, not 1 to 6 years, 11,000-ish cycle lifetime. And then you refresh the electrolytes and you get another 11,000 cycles. So they have an operational lifetime, estimated lifetime, of 35 years. That's huge as compared to 1 to maybe 6 years for a lead acid battery. They have a shelf life of 85 years. So you could have spares sitting on a shelf. And the shelf life is 85 years. I'm sorry, they have 30-year daily use rating, 85-year shelf life. So much more robust batteries. They're built specifically for things like this rather than adapted to things like this, unlike a lead acid battery. So, and you can get them in 12, I think I discussed this, 12, 24, 48 volt. And again, consult your electrical professional because it matters. They are considerably more expensive. One 12 volt, 100 amp hour battery of the nickel iron variety, not the lithium iron, the nickel iron variety is $1,100. One of them. By comparison, what's called a group 27 lead acid battery, 12 volt, which group 27 means it has 100-ish amp hours, because there are different ratings on different types of batteries, and again, all the blah blah blahs, all of them. But a group 27-ish style battery, lead acid battery, traditional battery, is going to be anywhere between $100 to $220, and then the mid-range is about $220, and then the high end, they're $400 a piece. But we'll just say at $220, they're 1/5 the cost of one of these nickel iron batteries. However, they have a rated life of 1 to 6 years, not 30 years. They have a rated deep cycle discharge to 300 to 900 cycles. rather than 11,000 cycles. And they don't have the shelf life that one of these Edison nickel iron batteries has. So ultimately, it's a matter of looking at where is your ROI, return on investment. How much money are you going to throw at this thing for how long? I have said repeatedly that the #1 issue with renewable energy on a grid scale is that our capacitor technology sucks. We can't store all the electrons we produce. This is a great way to do a better job at that on a decentralized capacity at your house, for your homestead, for your light industrial park, for your manufacturing concern, for your small things. Like, to us, they may be huge, but compared to the grid, they're tiny. I believe they're a very good investment if you can swing the upfront cost. I believe it's also probably going to be a little bit more difficult to piecemeal a system together at $1,100 a battery. So if you're building from the ground up and you can afford to do it on the front end, I think it's very wise to purchase these batteries as a battery array for your backup, rather than purchase a whole bunch of lead acid batteries. Because if you do the cost analysis over the lifetime of the project, you're probably going to spend more and have a higher utilization of your time and labor on lead acid batteries than you are with these nickel iron batteries. But you have to have the money to swing it up front. So that is, in a nutshell, everything I know about nickel iron batteries, iron Edison batteries, as compared to lead acid batteries. I'm not the consummate expert on this. I know enough to be dangerous. There are consummate experts, and I really would implore you that if you're considering something like this, please talk to them and find out if it's worth your time, energy, money, your hard-earned fiat currency. I believe that it is, and we will likely do something with iron Edison batteries here in the future as we move forward on this homestead. But $1,100 a battery is a hard pill to swallow. That's a big deal. It's a really big deal. But what you get for that, the ability to basically step away from it, check on it every 6 weeks. Oh yeah, it's good. All right, cool. Next. And the longevity that comes with that is huge. And the shelf life. I mean, you talk about, I just got an email from a guy recently, like, how do I harden my renewable energy system at my house? Short answer, I don't think you do. I think you dig a hole in the ground and you have your bunker, and in your bunker you have redundant components that if when the grid blows up, or a CME or an EMP or whatever, you have redundant components. To be able to store redundant components for 85 years that's a big deal. That's a really big deal. So again, you got to have the scratch though, man. Listen, man, Mr. Raging Rhino, I hope that helps. And if you guys have anything to add to the conversation, please do. You know the drill. You know where the comments are. Have fun.